Okay, welcome back. Today we're going to complete our discussion about scatter plots by talking about trend lines and using trend lines to predict information. So the first thing I'm going to do is create the scatter plot. So here, this is a scatter plot that shows the distance that someone runs and the time it takes them to run it. So it looks like it's a woman named Joyce's running data. So I'm going to quickly make a scatter plot here. So let's just observe here. Again, we're in quadrant 1. The x-axis is the miles that she ran, and the y-axis is the time that she took to run those miles. So here we have 4 and 38. Let's see, it's going up by 5, so it would be about here. And then we have 225, which would be about here, exactly here. 17. So let me just check these off as I do it. 216, so 2 and there's 15 and 16. 326, 325, 26 right there. 5 and 55 would be here. 220 would be there, okay. 445, so 445 would be here. And finally, 331 would be here. Okay, so look, this is a scatter plot. So you can see that some days she runs a distance of 4 miles in 30 minutes, and other days she runs a distance of 4 miles in 45 minutes. So you can see that her pace isn't always consistent, or exactly consistent between days, and that makes sense because it's it's not a machine doing the running; it's a human doing running. Okay. So when a scatter plot shows a linear association, you can use a line. So this shows a linear association because, again, we talked about clusters, and the clusters, these points appear to be clustered around a line. So when it shows as opposed to, for instance, a curve, right? They look like they're clustered around a line as opposed to something that's curving upward. So when this is the case, we can use a line to fit. We call it fitting to the data. Okay, we can use a straight line to sort of generalize about the distance that she runs versus the time it takes her to run that in the day. So what we want to do is we want to think about putting this line here. And the way that we think about it, it's called a trend line, okay? Or the other way of, the other name that it's known for is the line of best fit. So we want to use a straight edge to draw a line that has about the same number of points above it as it has below it. Okay. We want to ignore any outliers. So when we do that, let me push this down a little bit. Let me grab my ruler here. So the easiest thing is when you have oops, just flip to here. We're not using the measuring properties of a ruler. We're just using the properties of a ruler that would help us. We're just using the straightness of the ruler essentially. Oh, my ruler doesn't apparently want to turn. Oh, there it goes. Okay, so I want to use my ruler to get it so that there's an equal amount of points above and below it. And notice I'm putting mine through the origin, but your trend line doesn't necessarily go through the origin. So here, and in fact, I don't think mine's actually going to go through the origin either. Not every trend line will go through the origin. Okay, so here I would like to draw a line right here. Okay, and then let's pull this away. Okay, so here's my trend line. It looks like there's, well, let me make it a little bit better. I want equal points above and below it, so this is about equal. And the other thing that you want to remember is ignore any outliers. So it's okay if this point's a little bit far above the line. If it were an outlier to begin with, if it wasn't part of the clustering around the line, then we want to ignore that. Okay, now the next part is how to use a trend line or a line of best fit in order to predict a data point. So here you have we want to figure out how long it will take Joyce to run about 4.5 miles. And again, it's telling me to use the trend line, not to use the data here. So even if you had 4.5 miles here and you had a value here, you do not use the table in order to do this. The reason why you predict a trend line, you use a trend line, is to find sort of an average of the speed at which she's running. And then after you make the trend line, you want to really sort of forget the table, and you want to use the trend line to make the predictions, right? Because the table is based, it's sort of like these individual data points aren't as accurate as if we take all the data points together and make sort of an average rate at which she's running. So if we want to look at 4.5 miles, that would be here. So let me go ahead and follow this up. This would be 4.5 miles. And this appears to be at about 45 minutes. So it would take approximately 45 minutes to run 4.5 miles. Now, it's not always going to be right on a grid line. For us, it was fairly simple. And again, my line of best fit doesn't necessarily go through my origin. All I'm taking into account for my trend line or my line of best fit is that there's equal points above and below, disregarding outliers. Okay. Now, if we were asked to find the equation of a trend line, like here, the scatter plot's already been created, and we want to find the equation of it. So this shows the relationship between the number of chapters and the total number of pages for several books. So for instance, this point right here would be about, let's see, this would be 16, this would be in between. It's about 17 chapters, and this page value seems to be about 160 pages. Okay, so we would expect as the chapters increase that the pages also increase. So this shows a positive relationship between chapters and pages. That makes sense. Like the more chapters a book has, the more pages it's bound to have, right? So it's a positive association. Okay, if I want to find the equation of the trend line, I want to disregard the scatter plots. Remember, after you've built the trend line, you're building the trend line from the scatter plots. After you've done that, you essentially don't even really look at the scatter plots anymore, okay, or the points in the scatter plot anymore. You just use the trend line as a way to predict values and as a way to find the equation. Okay, so I'm going to pick 2 points that the trend line goes through, right? Now notice these are not 2 points that are in the original data set. They're not part of the scatter plot, but they are part of my, my equation of my line. So here I have the point 16, 160. Okay, and here I have a nice point here that would be 8, and 80. Okay, so I'm going to use 2 of these points, and I'm going to find the slope and find the y-intercept from these points. So remember, finding slope, we line them up vertically. Okay, we take 160 minus 80 over, so we take the change in, remember it's y2 minus y1 over x2 minus x1. So if this is 0.2 and this is 0.1, then this is y2 and y1. So 160 minus 80 and 16 minus 8 would be 80 over 8, which would be 10. So there's my slope. My slope is 10. Remember, this looks like it's going through the origin, but let's just make sure, because it doesn't necessarily have to go through the origin. It might go, like your y-intercept might be 1, and you wouldn't be able to tell the difference because that's so close, right? The intervals here are 20, so, and here, this didn't need to have a break because we're increasing by 20. So the intervals here are 20, so you wouldn't be able to tell the difference between the origin and the point, the y-intercept of 1. So let's go ahead and take our point here. So we have 80 is equal to the slope times 8 plus b. And recall what I'm doing is I'm using the form of the equation y equals mx plus b. And I'm substituting in the value. I'm just grabbing one of the points. I just happen to choose this one. I could have chosen the other one, and I'm substituting the y value in here, the slope that I just derived, and the x value in order to solve for b. Okay, so here I have 80 is equal to 80 plus b, and it does turn out that the y-intercept is 0. So my equation is y is equal to 10x. Okay, and that means that for every 10 for every 10 pages, it's about 1 more chapter, right? And so we talked today about, we continued our discussion about scatter plots by adding lines of best fit or trend lines to them, and we were able to use trend lines to predict information, and also we were able to find the equation of a trend line. And that's the end of the lesson for today.